So good afternoon, everybody. Let's start our section with fundamental concept on neural network, which tends to deep learning. Okay. Is it visible?
Yes, yes.
Okay. Let's go to the neural network. See this figure. These are the neurons on your brain. Okay. These are all are your neurons on the brain. And how our brain is working, scientists try to extract that concept and do the same way the machine, explore the way the brain working and try to input that concept inside the machine so that machine will work like human brain. Okay, so let's go discuss. So, okay. So MC College, first the neural network started from the MC College and Peirce on 1943. They designed the first neural network, and which is now tends to deep learning concept. Okay, that those concepts still now working. So is follow that artificial neural network follows the activities of the human neurons. Actually, in human brain, at the time of one, he or she has 100 billions neurons. Okay, 100 billions neurons. You can say neurons are. See here, the in the brain, these are, you can say, the neurons. Okay. So after when gradually you age is increasing, okay, the neurons go on increasing. Okay. One neuron connected to others, 1 lakh neurons. Though neurons, that is 100 billion neurons, and they are increasing gradually when your age is increasing. And again, one neuron connected to minimum 1 lakh other neurons. Okay. So neurons are connected in this way on your brain system. And the signal, there is the signal between the neurons are going on. And that neuron going on signals means that it electrochemical signals are going on, move there between the neurons. After that electrochemical signals transmit, the sum of all signal on a time duration, in a time interval, the neurons go on moving, giving the electrochemical signals, and at this in some time period the signal is summed, and when that signal is reacted reach certain point, you can say that point as the threshold. Certain point, it will fire, it will fire and reach to other neurons for do some work. Okay, so that is the concept behind the neurons, human neuron. You see, this is a neurons, and here what's happened, these are connected to through the dendrite, 1 lakh, minimum 1 lakh other neurons through these dendrites. Okay, through this, these are called dendrites. That is one action. One action is there. Here some after coming through the dendrites from the other neurons, signal is coming. When it is coming, when it reaches the threshold, other neuron reach the threshold, it will pass through it. We'll go to that later. First is that here what's happened, when the signal is coming from different dendrites, it will transmit, some reaction is performed here, and it transmitting through these actions. Okay, moving through this action. When is in the time interval, when is go on moving here and go on moving here, is go to different um, actions is there. There is so many other concept in the your brain system. There through that is going the signals, and this signal is passing it meeting at a point that is called synapses. Okay, here you see that this is the dendrites connected to this neurons, and this dendrite is connected to another neuron's actions. At that point where they are meeting, it is called synapses. Okay, that synapses here also some chemical action. Here has some strength. According to the here, this transmission again some strength is there, and they are mixing, so some reaction is happen. If it is meets some threshold, then the sum of it come to here. Okay, otherwise according to this strength it will come to here. So this is about your human brain neurons, and correspondingly how artificial neural network is working, we will discuss. Okay, a neuron is a cell body. Branching input structure is called dendrite, and branching output structures is called the axons. Axon connected to dendrites via the synapses. There, whatever signal will go through these actions, that are again modified at the at here synapses. Chemical reaction it's also happened there. So here then electrochemical signals are propagated from the dendrite input through the cell body and down the action to other neurons. Moreover, is happening is that some signal is coming through the dendrite to the cells. Then in that cell, some electrochemical signal is performed. Then it go through the down action to the other neuron. Okay. And that neuron signal will go to other neurons, fire. That neuron is what the signal is fire to throw the action when it meet the threshold values. Okay, at certain threshold is there, certain level of fire must be there, chemical reaction must be there. If it then only it fire. Okay. So synapses vary in stage. In the synapses concept that how synapses connections are. It may be a large signal, it may be a weak signal connections. So this concept is extracted our artificial neural network, which is also a machine learning. Okay, mimic the function and structures of the human brain. And here, what often you will consider in the artificial neural network corresponding to the neurons, you will consider some neurons, and the way dendrite is come as the input, you also consider the synapses, that is some signal is there also strength is increase or decrease. That thing we also consider. Again, you are saying the firing concept, that thing also consider in our artificial neural network. So let's see how we'll first one, you will basic thing will go discussed. Okay. So you have, as I already explained you have tabular data. You have the features value, and you have the target value. You may have the target value, you may not have the target value. This thing we discussed. Here it was happened. Whatever input is there in the table we get, that is the features, is like in the synapses. The your coming input is coming through the action. Then you have some synapses value. So here also you will see, consider the synapses value as the weights. Okay, what will be the input? It will be multiplied with some synapses value, or here you can say weights also. It is called synapses or weights. Okay, then some another thing is that some bias is added here. when the chemical, the concept is that when you are considering this neurons, this input is coming, as input is coming somehow, then some is a perceived value of the cell is also there. Which cell is working for what? Then for the eye, some neuron is working. For the leg, another neuron is working in your brain. So that neuron have some perceived value. So that perceived value here we are considering as the biased value, added bias. So some biased is added here. Then all are added. Uh, then it we are considering some threshold value concept. So the threshold value is considered in terms of the activation functions. Okay, so mathematically you can write here that if you have input is x, n number of input, that is x1, x2, x3 up to xn inputs, and if you say that your output is y in the supervised learning case, unsupervised case is different, we'll discuss. So y, then you will write here y is equal to summation of then you are multiplying here input with the weights, so xi into weight, corresponding weight. Is no weight is different for the different input, you can give different weight. Here only I have written on w, but you have to write here wi. Okay, so what's happened here, you will consider xi in the wi. Here I have written rightly, here by mistake. 1 minute, I am correcting this one. Here I should write okay. So here xi wi at multiplied, then input is multiplied with the synapses values, then they are added. Okay, all dendrites, through the all dendrites, all input is coming, n number of dendrites there, n number of input you will consider. Like in the table, you will consider the features of the n number of features. Then correspondingly, some weight is multiplied. You can say that is the synapses weight. So that is multiplied, then it is added. Again, your since your neuron have some perceived values, so correspond to it, you can add here B. Okay, by some biased value is according to which neuron you are considering, you will consider some biased value. Then you also add this one. All are added. Then since you are considering that is a firing concept, is reach some threshold, firing is reach some threshold, then only it will fire, it will go through the dendrite as the input to other neurons. So for that, correspondingly, one activation function is considered here. So activation whole is added, then on that you are using the activation function, then you are getting this output as y. Okay. So this is about your neuron, fundamental concept. One neuron means this work. One neuron means totally this work. Okay, with the activations functions. Then you see here graphically it is structured. You have input, n number of input, all input are multiplied it with some weights value. Each neuron have some perceived value, that is the biased. All are added. After adding, you will use on this Z, you will use some activation function. The activate, there is so many different type of activation function is there. According to our data output, we will consider which activation function is applicable for the which data set. And finally, after using the activation function, you are getting the output. Okay. So This diagram visualizes how inputs are weighted, some with a bias, then pass through an activation function and produce the final output. Okay, one neuron, fundamental concept is this one. What is this activation function? Let's go to what this thing is very simple. You have the tabular data. You have the tabular data, and those are multiplied with the weights value. That is the tabular data features. These are the features, not instant. These are the features multiplied with the some weights value. They are added. Then some biased value is fixed. Then some activation function is out. Then you are getting the output. One thing is that when data is given to you, only features value. These features x1 to xn is given to you, and this y is given to you. Then how you find this weights value, how you find this b value, how you find this activation function? These three are the concept you need to find, so that when the input you will get the corresponding output value. In case of the supervised machine learning, what happened? You have the tabular data, and in the tabular data, you have the features value is given and corresponding output value is given. Okay. So how you find? Our question is in the neural network, our question is in your brain what they are doing, we don't know. How they are doing some chemical reaction, all these things. Correspondingly, we just find out. You just in the neuron, we said that we whatever input is there, some multiply, added, jet, and activation function is it. What are these things? How you find this? The question is now how to find this biased value, weights value, and the activation function in the neural network. So in the machine learning tags is what algorithm we will use here, so that from the data set x1 to xn, which output is white, find out the weights value and the biased value and the activation functions. This is the question now. So first of all, let's discuss what is this activation. This is simple thing. You will add, multiply. We'll go to how to find weights. We'll go. First of all, let's see what is activation functions. So there is different type of activation. According to which, what is the output value y, correspondingly you will consider what is the activation function. So see here, there is different type of activation functions. One is the thresholding activation function. Here what's happened, you will find some threshold value, let's say theta, and if the whatever x value you get, x value means what? Is z. Here is z. The z is this one. What z you have get, if that z value is greater than theta, then you say that the whole fx value is 1. If the z value is less than equal to theta, here it is written x, less than theta, this threshold, then you will say the output is 0. That means y value is 0 if x value is, z value is less than equal to threshold value, and y value is equal to 1. Y means output value 1 if z value is greater than some threshold value, that is theta. Then how you find this theta value? What is that value? You will consider here, so that it will get. Then where you can use the 1 and 0. If your output y label value is yes and no, 1 and 0, two type of value, there you can use this threshold function, activation function. Okay. When you will use this threshold holding function, when the output is equal to two types, y value is two types, either 0 or 1. Okay. For the 1, you encode some, for some string value, you may encode, for the yes, you may encode 1, and for no, you may encode 0, or you may digits is there, digits not there. Two value, binary value, two value will be a possible value for the y value. Y value may not be two value, may not be one, may not be three value. It may be regression value, continuous value. Okay, it may be five type of values, categorical value. So always threshold function is not one. Okay. So here, when only this value is 1, 0, you may apply this activation functions. Another activation function is signum function. That is, if x value, you here also you how this uh, activation function diagram is shown, you will fix this is the x input, x, this z value or x value here, then fx is this one, fx is this one. You will consider the theta input or the input value. You are considering for the theta, then it is if the less than equal to theta, then the value is 1, is 0. If greater than theta, from here just input is after x-axis, after this one, this is 1, y value is 1. Similarly, signum functions, here what's happened? Your input is considered -1, sorry, output is considered -1 or +1. When it lay greater than equal to greater than theta, output is +1. When the value is less than equal to theta, value is -1. So when the output you are considering in this polar form, that is +-1 form, then you can use this threshold value, this activation function. Another is the sigmoidal function. Sigmoidal function is your 1 by 1 plus e to the power minus alpha x. What will be its output value? Where you are considering here, little bit needed to know your z value, or here it is x value. Z value is lies between in the real axis here. What will be your Z value? It may be negative value, may be 0, may be greater than 0 output value, Z value. Okay. If this, then what will be output? Output will be lies between. Output means you are considering the fx value here, activation fx value, which is also the output for your neural network output, that is y value. So here the value is lies between 0 to 1. Okay, the value is lies. What the output it will give? The value give between 0 and 1. That is the probabilities value. Okay, if the output is this, what is the probability that it belongs to some class? Suppose you have written, for you are studying that whether there is a disease, there is hypertension, or there is diabetes, or there is some. Suppose you have your output is more than one categorical value. You are considering some digits option differ. It is different option is given. Suppose you are considering 3 type of output, that categorical output. Instead of 2 type binary 0, 1, you have 3 type of. Then if you are testing for first type, what is the probability that the instance is saying that it belongs to this class, so one type, category type class? Then here you will find the probability of it belongs to that class. If you use this activation function, it will show you what is the probability that it belongs to class C1. What is the probability that it is belongs to class C2? What is the probability that it belongs to class C3? It will show you the probabilities values. Okay. And if you have 3 classes, for all classes, it will show you the probabilities values. Among them, which is the highest value, that will be considered that the instances belong to that class. Okay. So sigmoidal function is used when you will use the uh, probabilities value for the for belongs to a class. Generally, when two classes, you may use the threshold value, but for the multi classes, probability value are derived for the classes. Then which is the maximum probability that will be concluded as the class for the instance, target value for the instance. So here is that what is the alpha value? X is that your output after this one is your X. This one here Z is written and there I have written the X. Okay, Fx here, X. So then what this alpha value? You see here, if you take the alpha value is 1, the curve is like this. Okay. If you take the alpha value 0.5, the curve will be like this. If the alpha value is 2, the curve is like this. That means what is the probabilities varies. That means if you are seeing that the curve is like this, you are finding when the probability is very at the a very last value, you can find that the probabilities is 1 or like this you will find accordingly. Okay. So here when it becomes 1, very close to 1. Again, even negative, you if you are taking the alpha value is 2, then the you very close, immediately you find that after -2, you will find that the is probability value is 0. Okay. Similarly, for the this one alpha is 1, you are finding here 0. So when it is suitable to take according to your instances, according to your data set, it is observed this alpha value will be fixed. And here what happened, this alpha value is called hyperparameter. Hyperparameter. Generally, what happened? Here is slope parameter also. Here saying slope parameter. These are for our neural network. This weights value are called the parameters. Beta is a parameter. Sorry, B is a bias value. B is a parameter. These weights are the parameters. Okay, but here when you are considering activation function theta, this threshold value theta, these alpha value, these are called hyperparameter. Okay. And you have to also, when you take the validation data set, there you will fix what should be the alpha value. It's a very difficult task also to find the alpha value. So you will splitting the data set into 3 parts. One part you are training the model, and validation part you have to fix what alpha value will be taken so that it will give the correct output, correct probabilities values. Okay. At the training time, it will be first, you will take randomly weight value, randomly bias value, randomly alpha value, or whatever the range is given, you have to take the alpha value, correspondingly some random alpha value is taken. Then when you are go on finding that, when you will train your model one by one, you find how much error is coming, correspondingly those value will be changed. And finally, the number of training data, if you have the 100 data row, then 100 times it will change, and final after at the 100 time, after 100 iteration, you will get the suitable alpha value, and that weights value and that bias value, all value you will find. Then another activation function is your tan hx. Then what happened here? Here also tan hx value is lies between -1 to 1. When your value will, output will be from -1 to 1, then you will consider this activation function. Generally, activation function is fixed basing on what is your output. Okay. There is so many other activation function is there, that is sigmoid activation function and ReLU activation function. I have not written here. ReLU activation functions means it will take what it is, and some activation function is that it take the absolute value. What if it will not take the negative value, whatever x value or z value will be there, it will take its positive value. And ReLU activations function, what happen, it will what it is, it will take that. In case of the regression, you will use the ReLU activation function. And another is there softmax activation functions. Another is there so many Swiss ReLU activation functions. So there is so many activation function you can use, and those activation function is decided to use according to your output value, y value. For the regression you will use the ReLU activation functions. For the classification, what you will use, so basing on the activation output, you will consider your activation function. So this is about your neurons. Okay, one neuron, one single neuron, and the neuron is also called the perceptron. Whole system, what activities I explain here, this is also called a perceptron. Okay, this is whole one. You can take more than one neurons and train your model. You can take more than one neuron also to train the model, so that when there is a complex data set like image data set, signal data set, video data set, it can be handled uh, good way. Another thing is that data may be some data, tabular form data you have written, you had, and you are doing just multiplying some weight values and add value, then using some activation function, it will not go treasure. And what this way of interpretation, finally what you will find, a model which is this model, this using fx. Okay, fx will give fz, you will give the output, this fz, and here you will fix some weights value. But this how many weights value you will change by considering suitable weights value, training frequently too much of data, still it will not give the right answer, right accuracy. In those case, you can use more than this interpretation is your linear equation. You are linearly interpreting the this inputs data. You can non-linearly interpret this input data, okay, by considering is the value non-linearly. Okay, you are directly linear means what? You are directly x1 is multiplied with the w1. If you are saying the nonlinear means x square, degree of inputs is increasing, x square or x cube, x 4. Like this, you will consider here another input you will take x square, another input you will take x 4, x3 cube, x3 to the power 4. Like this, you will combine it. Then if you will do some work, then the result may give you the better. Okay, the result performance of the model will give. Instead of writing this linear equation, this is a linear equation, and that is just a line. Okay, instead of that, if you will consider the like curve like partitioning, so you will consider interpreting the inputs data non-linearly instead of linearly. You may get the good result. Okay, generally, if you interpreting the in case of the complex data structures, when or it may be tabular data, it may be image data, maybe signal data, maybe time series data, maybe video data, any data. If your complex structure way you will consider, you non-linearly interpret it, you must get a good model for the prediction and accurate result. Okay, so for that it's not directly, you are not going to do the nonlinear interpretation. You are considering linear in the middle of linear and nonlinear by considering here the different weights value in different way, and the this, instead of considering one neuron, you will consider more than one neuron here. You will combine different way in so that you can get a non-linear form. It directly you are not doing the x square x cube, but when you are frequently using this weights value, you are multiplying different way to them, then it consider as a equivalent to a non-linear interpretation. So this, if you consider more than one neurons, more than, there is a concept called layer, we'll go to that, more than one layers, and they are again this work will be done, this same thing will be done, but different frequently these things will done, so that the result will be non-linearly interpreting the inputs data, so that when you get the output you will get the accurate result. So here you see, here is another architecture structures. There we have one neuron. Here we have the three neurons. Okay, three neurons. N number of inputs. N number of inputs are correspondingly multiplied with the weights value. Then they are added same way is performed. Each neuron have their corresponding bias value. This neuron have different bias value. This neuron have different bias value. Same thing, and in your human brain. Human brain, each neuron have their own value. Okay. For the eyes you are considering one neuron, for the leg you are considering other neuron, for the ear you are considering other neuron. So they have different value. Like that you can say V1, V2, V3, they are different. Okay, biased value. Again, this weights is also different from different neurons. For here, this neuron, if you are saying the neuron 1, this one, neuron 1, 2, 1, this one, another neuron, this is another neuron. So X1 is connected to X2 is connected, X3 connected, Xn is connected, all are connected to here. Again, all are connected to here also, all are connected to here also. And all have different weights value. Okay, for the neuron, first neuron, the weights W11, W12, W13 up to W1n. For the second neuron, you have W21, W22, W23, W2, W2n. For the third neuron, you have W31, W32, W33 up to W3n. Okay, like this we will consider for the third neurons. Then some biased value is added. Then you have this neuron, you will give the Z1 value, this neuron will give different value, that is Z2 value, this neuron will give you the value Z3 value. Again, here you can use any activation function. It may be ReLU, it may be sigmoid, it may be threshold. Any you can heterogeneous activation function can be taken, homogeneous activation function can be taken. That means you can take different for the different neuron, different activation function can be used, or you can one type of activation function can be used for all neurons. And these are processed parallelly. If you have three processors, a different processor, you can work on different time. Parallelly, they can also work. Okay. So after getting all the result, you will get corresponding output. That is your single layer neural network. One layer is here. All are connected to input layer. All are connected to input data. Okay, so this one is one layer because all are connected to input data of first layer, one layer. First layer, this is the one layer. This is also called the output layer. This is called the single layer. One layer. In the previous case also, here you will say one layer, and the one layer, first layer is connected to input data. First layer is connected to input data. In the first layer you have one neuron, and that is also called the, since it is directly giving to the output, that is also called the output neuron, and output layer also called. Here first layer is your output layer, is the single neuron. Here you have first layer is the output layer, because after this input you are getting these three neurons, and these three neurons is passed to as the three type of output. So this is also your output layer, because after that you are getting the output. Here also you, after this neuron you are getting the output. Okay, here what happened, one circle is given for the activation function. Actually combinedly this is one neuron, combinedly this is one neuron. One neuron means he will do this work. Z3 activation function. So this is your input, this is called your input layer, this is called your layer, first layer. Since after that this layer you are getting the output, this is also called the output layer. Your first layer is equal to your output layer here. If you will consider another layer, that means another layer means after that again you will consider another one or two neurons, and these three neurons after this one here also from the first layer, they are connected. Again weights is multiply, they are connected to one neuron, again weights, then two neuron. You can take next layer, you will take one neuron you can take, two neuron can take, three neuron can take, four neuron can take, and all are again do the same way here done. Some weight is multiplied, again added, there also you have the biased value, they are added, you will get some value, then also again activation function will be used, then it come the output. So in that case you will say this is the first layer, and next is your second layer, and second layer is your output layer. Second layer is equal to your output layer, because after second layer you are getting the output. So in that case you have the two layer neural network. Here you have the single layer neural network. So neural network basic concept is that for neuron, basic basic tone is your neuron, or it is also called the perceptron. Okay, basic structures is called your neuron. Okay, then this is the concept, one concept I said you, that here you are considering, instead of considering one neuron in the one layer, this is one layer you are considering three neurons, and they are working like this. Okay, they are, if you will consider, this is also linearly interpreting the data, but if you will consider more than one layer, then it will interpreting the input data non-linearly. Okay, so in there also their non-linear concept will come somehow, not exactly non-linear, between the linear and non-linear there. So considering that way, how many layer is there, how many neurons is there, how neurons are connected between them, according to that you can consider neural network architectures. And it's a very difficult task for a problem, for a project, or for a problem. What should be the neural network architectures? First thing we face the difficult, how you find the activation function, how you find the biased value, how you find the weights value. Second is that how many neurons you will consider, and how they are connected, how many layer we will take. All these things you need to decide. This is also a very difficult task. when you are considering the number of layer is greater than 1, here I said you 1 layer, because after input data you are getting this 3. After that, there is no neuron directly output. So you are saying that 1 layer, single layer. If there is another layer we'll consider, then you can say the multiple layer. And if there is a multiple layer, then deep learning concept is introduced. After this, you have the machine learning, a traditional approach. After that, when you are considering another layer, then the deep learning is introduced here. Okay. According to number of layer, you are considering the structures of the layer, you are considering the deep learning. Oh, this is a very difficult task. So how many layer you will take? In each layer, how many neuron you will consider? How they will be connected? All these things are to be considered. Okay. And according to your problem statement, you will consider the structure. Still research is going on that, how to find the suitable structures for a problem. There is no specific rule is written still now to find the structures. You go on, train it, go on, do work on it frequently. Very thankful to our programming concept. Very quickly you are getting the result when you just change some architectures. You will add another neuron, you will delete a neuron, you connect between neuron in different way. So computer very speedily you are giving. If your processor is 16-bit processor and you will get high level configuration hardware, then you immediately get, so that you can immediately change the architectures and do the output. Still, if the data set is very high, then it is very difficult to find out which architecture need to be followed. Beside that, when you consider all the architectures, they can be categorized into 3 forms. One is the single layer feed-forward network, multi-layer feed-forward networks, another is the recurrent networks. Okay. Single layer concept I already explained you. Feed-forward network, what is the meaning of feed-forward, I also said you. Then there is another concept is that backward. Okay, we'll go to that. First of all, we'll see what is single feed-forward networks, multi-layer feed-forward networks, and recurrent networks. I will also implement this very simple data I will take manually and show you how they can be implemented using your Python and Python library. So this is your single LAN feed-forward networks, and here what's happened? The same thing, just I explain you, you are taking the input here, multiplying the weights, they have corresponding biased value, then you are getting the output. Here, this is the input data. This is not called the layer. Actually, in your neural network, input layer is not considered as a layer of the network. You are saying this is, you are not counting it as a layer in your deep learning architecture or the neural network architectures. Even if in your traditional artificial neural network architecture, input layer is said as the layer, but it is not count as a layer of a architectures. Here what's happened? The first layer is this one. Your layer is only one here. So it is called single layer. Layer means when you have the neuron. Neuron means here, don't confuse it that here it is circle symbol is given means it is neuron. No. Neuron means what I said you multiply input value with the weights value and add all with a biased value also. Then you will use the activation function. If you will do it that thing, perform that things, then you are saying that it is a neuron. Okay. So since you have after input data, you are considering only one layer here, and between this neuron there is no communication. See here, no arrow between the neurons here. So in that case, you are saying the single layer feed forward network. Why it is called the feed forward? You are not coming back here. You are in this here. Uh, Here, what's happened? You are just calculating, showing the output. You are not going back here to change the what weight first time you fixed, that is fixed. You are not going to change back calculating how the output, what is the output here, it is right or wrong. Accordingly, let's change here using some formula. There is so many formula is there to change the weights value if it is not giving the good accurate value. So here, if you are not using any formula, anything to change the weight value, you are at the starting point, you fix weight value in such a manner so that it will give good output. And in that case, you are not using any technique here to change the weights value. You may manually change those values according to your analysis of problem and guessing randomly. You can take the weights value. You are not going to chase at any way using any formula. In that case, you are saying that it is a feed forward neural network. Okay. There is a concept backward network in the back propagation, also called back. In the back propagation, there is so many formula is there. You can use any one formula and go to back and change the biased value and weights value using that formula. Then, hello, is there any doubt? Any doubt? Am I audible?
Yes, yes.
Any doubt? No. Okay. Okay. So here, this is the thing. Then we'll go for the multiple feed forward networks. In the multiple feed forward networks, you have more than one layer. See here, this is the input. Here I did not do the circle. I just write here the input 1, 2, 3, 4. Then you have the this is the input. Sorry. This is the input. This is the input layer. Input layer is not considered as input layer in the architecture. So here your fast layer, then you have added all here. Same way you do here. Here also you fix a weight value here. All weight value. You also have a biased value for this neuron. And this is connected to this. What is the output here you get? It is multiply with some weights value, add with a biased value, then use the activation function, then you get the output. Here you have how many neurons? This is 5 neuron in the first layer, hidden layer, and first layer, this is the input layer, this is the hidden layer, and this is the output layer. Since here you have more than one layer, that is, one is your output layer, another is hidden layer. So you can say this is the deep learning structures. Okay, this is the deep learning structures. So multi-layer means more than one layer. Excluding input layer, you are not considering input layer since input layer is not considered. So if you have minimum 2 number of layers, then you say that it is a multi-layer network. Okay, feed forward means here it is written a word feed forward. Whatever weights you consider here, also here, and the bias value you consider, that is final. You are not going back and changing those values. Okay, that is called feed forward. This is multi-layer feed forward neural network. Another is your recurrent neural network. Recurrent neural network, it will coming back again. If you are saying the recurring neural network, single layer recurrent neural network, then you see here, this is your input data, and these are doing the same work as I explained you previously. Weight is multiplied, then added, then biased is added, then use the activation function with this. Whatever output will come, Again it will come to here, again go on counting inside. Here also again go on doing. Here also go on doing. Recurrently. Recurrently you go on working. Still some condition is there to stop. Okay, this is also generally your grammar correction, all these things, sentences interpretation. In that case, your a time series data set, you are generally considering the recurrent neural network. So another is multi-layer recurrent neural network. You have the input layer, it is going to here, then it is another layer is there, is going to, is coming back. It may come to on like here, you can come like this, or it can come to start again. Again, where is the start layer? First layer, that is the not input layer. Another, it will come back again, calculate, go on calculating. This one is go on calculating. Like this will go coming back and go on calculating. This is different from your feed back propagations. Recurrent is what is the output? It is come back again, calculate as a input to this neuron. Okay. As input to this neuron. Okay, whatever calculation done, coming back, consider input to the another. That thing also can go to other neurons also to calculate. Similarly, before this one is coming here, then is coming to this first layer, and you can say this is the hidden layer, and coming here, all input is considered here. Again, this one is coming to calculate here. Here also same. And this thing is not only go to here only. This can be go to here. It can come to here also for the calculations. That is called the recurrent multi-layer. If there is more than one layer and coming back to first layer, then it is called multi-layer recurrent neural. So now we'll consider the learning concept, and I'll go details on the learning concept next class. But I'm just saying little bit about it. Learning is that learning here two type. Here I have written one type. I'll discuss all in the next class. Here I am saying first thing is learning concept is that how to consider that weight value and the biased value, and how to calculate that hyperparameter value. Hyperparameter, I already said you, when you are in the activation function, you are considering what is the threshold value. Some parameters is used inside the activation function that I said in case of the sigma function, that is 1 by 1 minus e to the power minus alpha z. Okay. So what is the alpha value? Like that you have some value is there, is used, that is called hyperparameter, that are trained. Moreover, here learning means you are training the free parameters. Free parameters means your weight value and the biased value. These are the major tags. Another learning concept is that what is the architecture, as I explained. How many neurons should be kept? How many layers should be kept? Is the recurrent? If you are considering the recurrent, what is the structure then? Then these are the thing consider. What is the architectures you are considering? How many neurons, how many layers, whether there will be recurrent neural network, then if you are using the backward method, then how it will be. These structure, considering that structures is another type of structural learning. That is called the structural learning. This is called the parameter learning. So parameter learning is one type, another is the structural learning. In the next class, we'll discuss about the learning. It's very mathematical concept is there. We'll discuss all. So now I am giving you what I explained here. This one, how you implement, how you implement using your Python. And that is also some libraries there. You can use those library instead of direct doing. So I already opened this one, I think. No. Let's see. This was Google Meet. Let's open the collab. So the this single architecture, single neuron architecture, this one. And single layer also. Activation function, that means if there is negative value, consider for the positive. A 0, and if it is positive value, then keep it as it. 0.5, another 2, minus 0.5, 1. So you have 4 features here. Okay, here you have the 4 features value tabular data. We'll work it with the tabular data. Next class I will show you with the tabular data. So here the 1 data I have given, then you randomly take the weights value. Since you have the 4 features values, so you will take 4 weights value here. Okay, you have take 0.2, 0.8, minus 0.5. This is randomly taken the weights value here. Then biased value is taken 2.0. Now what's happened? 1.5 will be multiplied with 0.2. 2 is multiplied with the 0.8, minus 0.5, and will be multiplied with the minus 0.5. 1 will be multiplied with the 1. Then it is added with the 2. And after that, you will use this activation function, this ReLU activation function. So I did here np dot. This is the you know already know that NumPy is allow your product dot product like this. This is the inputs. Inputs means this one. Correspondingly, it will multiply the weights value this one. Then it is added the neuron bias value. Then you have used the ReLU activation function. You already define here using this function. Then you call that ReLU function. Here directly, instead of calculating differently this value, it directly will calculate inside it. Then it use the ReLU activation. It will, if it is you after multiplying and adding also biased, what you find, you will, and then use the ReLU activation, find it will give you a positive number. The value will be 5.15. You can work out with your copy and find out that it is 5.15. 5.15. 2-layer architectures, and in the second layer, in the first layer you have taken 1 neuron. In the second layer you have taken okay, generated layer of neuron. Sorry, you have taken 1 layer with the 3 neurons. Okay, 3 neuron. Here I have taken 1 neurons. 1 or then if you taking the 3, then 3, you have the weight value 0.2, 0.8, minus 0.5, 1. This one. No, not this one. This is different one. And for the second neuron, for the 4 features, you consider 0.5, minus 0.9, 0.1, info, and the third neuron you consider the weight for 4 features of the minus 0.3, 0.1, 0.8, minus 0.2. Then correspondingly, you will multiply it the input data. Input data is your 2, 0.5 minus 0.0. Sorry. This is your for the biased value for the 3 neuron. Okay, input is already here. This one is your three neurons have corresponding bias value. First neuron have bias value 2, second neurons have the bias value 0.5, third neurons have the bias value minus 0. Minus 1.0. So you multiply for the second neuron, you multiply input data correspondingly these weights and add with the 0.5. In the for the third case, you will multiply us, then add with gen. Then you will use for all evaluation correspondingly, you will use the ReLU activations functions. If you do this one according to your Python syntax, you'll write np dot this layer weights into inputs. It will layer biased. This is correspondingly you can use the ReLU activations function. Then you get the output for the 3 neurons. First one will give you the 5.15. First one is positive, second one is your negative, third one also you will get the negative value. You just verify this one is your copy. Then you find the second and third one as negative. Since the second and third one is negative, so you get it will convert it to 0. So it becomes 0, 0. In this way, you will use here, and if there is more layer, you can use correspondingly do this one. And if it is 8, 9, 10, and there is too much calculation is there, it's difficult to do all this, you can use some library also to do. See here. One library is PyTorch. So you can write it out NN as NN. Nickname we have given in subform. So here you create an instance. Here NN layer. First you call this one instance. Then what you input here, your number of features is 4, and your output features is 3. Features is 3. Output is neuron. How many neurons you consider in the first layer or output layer? 3 neurons, so it is written as 3. Then you can write here the you have the weights value for corresponding 4 features. This is generated. Then the bias value also are generated here automatically. Then calculation and find out. I am just today saying what is the library can use. Another is the TensorFlow and given name as TF short form numpy as info. Here also you can call the call the function TF and 3 activation function ReLU. That means you have here 3 neurons you have created and activation function ReLU used. You can write here the according to threshold or according to activation function you will use, just call it. First of all, what you define Here are not needed. Here, so you can input the right here activation function. It will work. You can do the operation, call that tf.com value. It will automatically create this weights value and perform and give you the output. We'll go more on this on the next class. Today is complete. Any doubt, you just ask me. Any doubt?
Yes, any doubt you can ask. Hello? Om, Pratyush, any doubt is there?
No, sir.
Okay, fine. But assignment will be given. See.
Okay.
Okay. Thank you, ma'am. This much for today. So tomorrow we don't have any class.
Okay.
Okay. So day after tomorrow and that
That
means Thursday,
tomorrow.
Friday we have class. Tomorrow there will be no class. Fine.
Okay. Okay. Somebody has given the message.